those sorts of things.
Oh, the guy who doesn't even have
Omnivore.
that.
Oh, okay. Hang on. Let's see if I can.
It's really not that
remember.
complicated though. Like if they're pointing at the shade and then not at the shade, and that's why when it's changing, like how much better of an experiment do you need than that?
Yeah.
Mine worked.
Omni is a very strong point there.
I would want to see
No.
a
Omni's full of
a
shit.
kind of
Here it
control.
is. Look, Omni.
Omni's coming
This is
in
on
with
the
just
side of the thermometer. It tells you the size of the beam, and that's why I was 3 feet away, so I could average out a bigger area on the ground. Because when you're so close, like the area that I was shooting is not flat whatsoever, so you pick up hot pockets and shit like that. So this works,
Okay.
24 inches
I mean,
away is still pretty accurate for mine. Maybe the shitty one you were looking up is only up to 6 inches or so, but mine shoots up to 24 inches. No issues.
Can we just compare like what they claim? Like they see little squiggly lines on a computer and they're like, oh, those are gluons in a hypermatrix space-time continuum. And we're just doing a thermometer experiment showing that the shade is warmer, and that's so not done well enough.
It's got a 4-inch beam at 24 inches away. All right.
Okay.
So there you go. So it's not even that wide of a beam, right? That's
What
why
does that
1
mean,
foot
though?
off the ground.
Yeah. It's just basically that it has to be
What's
in
up?
the line of sight of the moon, and that
Yeah,
would be
see,
in the moonlight. That's
Yeah,
in the
Redford
moonlight.
Bear, we could see yours too. You were getting a couple degrees there. Or were you going back and forth there?
Yeah, I was, because it's a
Hold on.
spot that's
Hold
like
on,
been in the shade longer. Here, I can do it again.
Yeah, what were you getting there? You were getting a couple degrees. Here, I'll zoom the live stream in on your.
Cool.
I can only see Travis.
You got to
Same
click
here.
around to see the different
Redford
screen
just now.
shares because there's multiple.
Okay, so it's like ooh. I can't
Redford, I'm
remember.
showing yours on the live stream right now. So yeah, it's like zoomed into your. Oh wow, you're getting. Is that going back and forth? That's like 3-4 degrees.
Yeah.
different.
Yeah, it's quite. That was a lot. Yeah, that was a big degree change.
Yeah,
I can't see your screen. No.
yeah, I was getting like, so mine was just like I was hitting 51 and going down to 44, and I'm like, yeah, I mean it's literally just the eve of my house.
Can you do it again, Travis? I'm watching your screen now. I mean, I believe you. I was just doing it, but let's just see it one more time.
Yeah, no, for sure. I just was like, I can't figure out how to switch my camera around.
There's like a swivel button somewhere for the camera. That way your reading is not backwards, right?
Tell me if it's focused. Can you guys see it?
We see it,
but
but
the
the
numbers are
letters are backwards. Yeah, the numbers are backwards. But
49.8.
But yeah, we can just reverse it in our heads.
Right.
50.3.
Yeah. Okay, 50. 46,
People in Australia,
44.
anyone in
Wow.
Australia won't be having a problem right now. They'll be
40.
seeing it right side up.
Dude,
It's kind
you
of
got like a
enough,
6-degree difference, man.
It's like everybody's got like consistent results here. You know what
Wow,
I mean?
that's 6, 7. Is that even
Yeah.
7?
Yo,
That's a record.
it's about 6 something.
Like nobody's struggling. Nobody's struggling
I mean,
to read this. You know?
That's how you know
It's
that
like everybody that does it gets a result, right? No matter like different surfaces, same surfaces, there always seems to be some sort of result, and that result seems to be that Moonlight is colder.
Right.
Yeah.
They call this peer reviewed or peer verified or whatever.
Well, go ahead and
Replicated.
write it up and
It's-
completely
it's-
change physics if that's what's taking place, stupid flurf, okay?
It's just a bit idiot proof. It's a bit idiot proof to do it this way. I don't see what like getting a more specific really is going to say, other than this phenomena is occurring.
So Omnivore, is this interesting? Is this interesting that the moonlight is cold?
I
Definitely.
I do not. I'm not convinced that the moonlight is cold. However, if it is shown to be in a controlled experiment, yes. that
Okay,
would
but
be
you agree you
extremely
just saw like
Travis.
multiple demonstrations of it. Now I know what you're saying. If you want to see more controlled, that's fine. But I'm just saying
Sure.
yeah.
What's your explanation for the things that we just showed you? What do you think about that?
Do I
You're
need
doing
to
it
have
wrong.
an explanation?
You're just doing it wrong. Did you read the instructions?
Oh
his
gosh.
his mind is like
Have to do
literally
it
just
again.
struggling.
Have to do it again,
Can't
guys.
Did your
handle
world
it.
get a little
I-
less round?
I posted.
Do it again, Rifford.
I
I'm
posted
getting
some.
5
So
degrees difference, bro.
real
From
quick,
like
Yeah, I'll go back out in a bit and find more spots.
since
It's
I would
cold,
have,
actually.
I
'Cause you're in
posted
Canada.
a list of some
I
tests
know.
that people had done testing whether or not Moonlight was cold.
Yeah, but then did you expect
Okay, you
like
posted.
more
All right,
people
so
to
He's
look
getting
up?
hold on. I see what you posted. You posted a Danny Faulkner article
Mm-hmm.
from Answers in Genesis. Okay, and what is this being presented for exactly right now?
So an anti-flat earther. Okay, cool. Good source.
He might even be in here right
come
now.
on, man.
Is he in
He
here?
probably is. Creeping
I mean,
to get content for his next flat earth, anti-flat earth book. Yeah.
I mean, he goes by his name on this server. He is, but anyways, okay. So you posted that, all right. And next, I mean, it's been demonstrated right here directly multiple times. That's the thing. So if you just bought one of these thermometers for $20 off of Amazon and did it yourself, and you can control it in any way you want, and if you could measure the effect yourself, what more would you want than that?
Well, I would set up a control experiment, right? So I would want to make sure that I've got the same material in a controlled area. Part of it is covered, part of it isn't. I'm not sure that I would use the temperature gun like that. I might go for thermometer. I'd have to look at what other kinds of thermometers there are. I don't think that's a bad one.
Who's got the
but
fleur?
possibly putting thermometers into like a sand.
Jesse's
Basically,
proving it right now. So
a sand, not a sand.
All right,
pit,
let's
but-
go, Jesse. He's about to prove the same
Jesse,
exact thing with the fleur.
save the globe, Jesse. Save it.
He's about to kill the globe, man. All right.
is this
He's
going to
got
show where
something
the
up his-
bodies are buried?
Ken Wheeler did this with
Yeah,
thermal
I
warm
imaging
body under
and
there.
came back with
I've let
the
them
same
cool off
results you
long
guys
enough
are
that
coming
you
back
can't
with.
really tell.
Let's keep it all above board. What'd you say, Riggs? Your mic was a little muffled.
Oh, was it? Yeah, Ken Wheeler did this with thermal imaging also and came back with the same results you guys did.
Nice.
Nice. All right, Jesse,
Jesse.
where's the shade and where's the...
Yeah.
Tell us.
He's gonna
Where's the
tell us
shaded
everything.
area?
He's gonna
Do you
tell us
have
everything
Moonlight?
backwards.
Go to... Where's the north side of your house?
Oh, can you hear me?
Yep.
Now we
We
can.
can now.
Oh, now,
There you go.
yeah,
Okay,
now we can.
okay.
Yeah.
So wait,
the
this is a thermal imaging camera? Oh, we got you. Go ahead.
Yeah, it plugs into my phone on the USB, but yeah, it's a thermal imaging camera.
Come drink this water. Come drink this
the-
water.
The
Napalm.
moon, it's kind of
Sorry, my hot
cloudy,
rocket.
Yeah.
Sorry.
but
Don't
Like
shoot
no
the
cat.
sky, man.
you can see that the trees are still warm. The grass is cooling off a lot, but where you have like holes in the grass, this is bare dirt here or gravel. That's concrete there. It's still warm from the day, but the grass cools off a lot faster because it's got little contact with the ground.
Okay.
And there's my house. My
It
mower.
is it's
Do you
showing
have
180
shadows?
degrees. Like it'd be better if it was tilted 90 degrees for us, but maybe that's just how it shares. I don't know if there's any way to flip it.
Is this better?
That's better. Yep.
Oh, that is
Okay.
actually, yeah.
Do you have
Or-
any
or-
shadows
okay.
from the moonlight, Jesse?
Does this work or is this upside down?
Yeah.
That's
That
right
works.
side up for us now. Yeah.
Okay, cool.
Yeah, perfect. Yep.
Just pick a spot with the same material with moonlight and not moonlight.
Yeah.
Well, there's a lot of dark spots.
Go to like back of your house or something.
Yeah, check this out. My foot
That's-
leaves a warm spot.
That's gross.
Whoa,
Mhm.
that's pretty cool.
And I was picking that up with my infrared thermometer too when I would measure my like my footprint. So I stayed in the same spot as I did. I just moved my arm back and forth.
So
Well,
that's good.
look
This
at
is showing
that.
that sensitive enough to pick up on temperature changes.
That's pretty cool.
Yeah.
Just from putting your hand on it.
Hey, Gio,
It's getting
Geo.
hot in her.
Do you remember those shirts? Do you remember those shirts back in the day, the hypercolor shirts, where they would change color
Yeah,
based on your heat signature?
totally, dude. This reminds me of that. Those were awesome.
Yep.
Yeah, there's like those tie-dye shirts and stuff where like your heat
Yep.
would change the color.
Hypercolor. Yep.
And then the mood
Hypercolor.
rings. You guys got into the mood rings too?
No,
I've seen
no.
mood rings.
Oh
Wasn't a
yeah,
jewelry
the
guy.
mood
Those
rings.
are cool.
Of
Yeah.
course, those
Yeah,
are
freaky.
sweet. Yeah.
Freaky Freezy's gloves, the gloves that change color when it got cold out.
Or just like the stones. There's also
So
the ones that
Jesse,
are like they're not necessarily a ring. It's just a stone, and when you hold it, it starts to change color.
Yes.
I have nothing but
That's
sand
that's
out here,
blue.
so it's very
Kind of
consistent.
it reminds me of a Beastie Boys video.
Where's the moon?
All right, this is very cool, Jesse. Can you get to the point?
Yeah. Where's
Yeah.
the where's
man.
the
We-
shade from the moonlight?
Go to
Yeah.
north
I'm
side
trying
of
to
your
pat
house.
you on the back, bro, but you gotta hurry it up.
Yeah, you need to find a spot where depends on how full your moon is, but you need to find a spot or how clear it is in the position, but where you're basically like the thing that's shading it is pretty far away, so you don't really want anything too close. Then you want to get to where the shade line is dividing, you know what I mean, between shade and no shade. And as long as it's, I think, ideally far enough away to where you have like the same, environment, like there's no drastic difference in distance, and then you can ping back and forth. Now with that thing you're using, Jesse, I don't know what this is or isn't going to pick up, but if you could find an area where there's a clear differentiation between the moonlight and then on the same surface too, so you're not jumping surfaces, be interesting to see if that can pick anything up.
Yeah, I got an experiment planned for that. Right now, the moon's just hardly visible through the cloud layer, so there's no moon shadows now
Okay.
anyway. But
Oh,
what I
okay.
did want to show you, was how there's all kinds of hot spots and cold spots, just irrelevant of any moonlight or anything. So if you can't see that, you go out with your thermal gun.
How did I know that was going to happen?
Yeah, it's like you're in God mode on a huge planar Earth. Looking
Jesse,
from
your
thousands
Now I
of
have
calibration.
to buy one of these
What's
Your
that? They're only like
because I got
calibration
nothing
is,
but sand out here, Jesse. So it's and I do have a lot of hope. Like I'll flatten out an area, but I do want to run one with thermocouples and a couple of black bodies in plexiglass, one in the shade and one not in the shade, and they'll shut up Omni for sure.
Oh, like a thermocouple.
Yeah, I don't know.
Yeah, nice.
Yeah.
I've
Did
got
you-
some
I'll
moonlight.
put the
How-
thermocouple in the briquette, inside of the briquette, and then I'll cover both
That'd be some
briquettes
hot
with a
jazz right
plexiglass
there, yeah.
box.
If
We'll
you
just
want to
hit that.
shut me up,
Black
I'm
body.
curious as to how he came out on the inability to see the ISS. Did we solve that?
Relaxed. I already a long time ago when you left, I said I was wrong. You can resolve it. You see?
Oh, I didn't hear that.
No,
Okay.
I already said it again. I was incorrect, and you can resolve it because it was about 2 seconds.
You can
There you go. His
resolve
telescope
something.
can pick up a lot less than that.
Okay.
Happy now, Mr. Omni? So let's
Well,
stick to the point. Cold moonlight.
I'm totally good with it. You were just shouting at me to do the math, and I was like, "Yeah, I don't
Okay,
think so."
Omni, now
but-
say that
Well,
the moon is cold.
Yeah, Omnivore, like in terms of this cold moonlight thing, like you're seeing direct, evidence of them doing it, direct demonstration, and then you can do it yourself. So if you got, did it yourself as well, even under whatever control conditions you want, and if you also get the same result that
Then
everyone else does,
then I would conclude that something is very wrong with physics. Yeah. If
I mean,
I could
Dude,
not,
$20. Order one right now.
something I'd like to see is if you place something like a piece of plastic from inside on like between the moonlight and between the shadow to see if both sides of those are heating up or cooling down if you like lift it off the ground, you know?
What do you mean?
Like
Explain to me so I could do it right now.
So if you have any like big plastic lids or anything, right?
I do. Okay.
Do you think you could raise both ends of that off of the ground and put it where one half is in the moonlight and one half is in the shade? And then see if that
Okay.
heats up or cools down actively.
I can do that. Well, you can have it on the ground because the thermal conductivity should be the same.
I feel like
Mhm.
raising it off the
'Cause-
ground will just
Okay.
help reduce,
How far off the ground?
just not touching the ground pretty much.
Not okay, sure. I'll set it up on 2x4s because that's what I have handy. So, and it's a black lid. Let's go. Black body. That's what I'm talking about. All right, set it up in half in the moonlight.
So from all the demonstrations that were done,
shade.
though, it looked like the differences range from as low as 2 degrees and as high as 7. That was the range of what you guys just all showed. Between 2 to 7 degree difference.
I'm at 3,300 feet, so Travis got twice the elevation on me.
Oh, he's at 60, up in the 6,000s?
Yeah.
Oh, okay. Yeah, he had said that. I think I missed that part of what he said his altitude was. Yeah. Well, if that's very interesting as well, of course. Yeah, if the air's thinner, then you would get a bigger effect. Would that be the idea? Less attenuation?
Or he's closer. I've got no idea. Yeah.
Or just straight because it's closer.
He's closer to the moon.
Right.
As far as like the
All right, let me find.
as far as the medium, right, that you would be measuring off of, I mean, I was measuring off of wood chips. My entire yard is wood chips.
Yeah, but that's a consistent.
Yeah, my medium was consistent too. Yeah, I was just sand. Now I'm setting up the lid on 2x4s, so it's not touching the ground, and I'll let it normalize for. It's a pretty thin lid, so 5 minutes should be pretty good.
It's really a pretty simple experiment. Like, clearly it's the moonlight. That's the independent variable.
Does Omni approve of this message?
No,
This experiment, Omni? Is this going to be controlled enough?
Doesn't like.
I mean, it's revealing that it's worse than a bias. He's actually trying to hide this stuff.
The really wrong thing is that, and I'll say this: it's that like anything that comes back is going to be rejected because he doesn't understand the mechanism of how such a thing could work. Because he knows it can't happen with light, and I think if we understand like how every other way that we understand how to manipulate light, we can't make it cool stuff down. Like, right? Does the group agree with that?
Well, dude, I think what the problem is that
no. Like, where's the tech? Where's the tech that we can do this in a lab that you can actually cool? Because I don't think you can with a laser or anything. But we're just talking about light.
Well, if you can't replicate it in a lab, then it's clearly not science, right?
Wait, let's let Travis respond though. He was
okay.
Well, I just was
here. This is the new setup. So here's the lid. Half of it is in the moonlight, the right half, and the left half is in the shade, elevated off the ground. Should be good enough. Let's see if I'm getting readings already. All right.
Travis, go ahead too, bro.
The moonlight.
Your mic was.
This is the shade. Look at that already, man. Okay. Moonlight. Okay. Shade. Okay. Back in the moonlight.
That one's fluctuating about 0.9.
This is the shade.
Ooh, now it's a little bit like 1, a little over 1. So it's
Yeah,
on the
I'm
lower
trying
end.
to hit the same exact spot every time, but yeah.
This is a plastic material.
But there's it's super thin plastic, so the wind will affect the heat transfer by convection quite a bit. Right? So this is still the moonlight. I'm gonna go over to the shade. Dude, yeah, that's absolute. Like I'm more than convinced, man. Back in the moonlight. Okay. Go back to the shade.
Yep, that's definitely jumping.
I'm good.
Hey, I just wanted to add
done.
Oh, one thing I wanted to tell you guys. So I heard about this when I lived in Alaska, and this is something interesting too, right? So I was like, no way, like I want to try it. But when I was in Alaska, the moonlight was warmer, but granted, it was like cold as shit, right? So okay, I know, watch my mouth. Anyhow, I just something I wanted to add.
You said that, but I just dropped a vid that I made in the dead of winter, and it was like below 0 in the moonlight, and it was about 5 degrees in the shade. If you want to clip on it, if you want to click on the video, it's less than a minute.
Yeah,
What was the temperature in
trying to
Alaska
poo-poo
at
the
the time?
thing or say that there's nothing, you know what I mean? Like I just did it in my yard here down in the lower 48, and I've got a crazy difference. I'm just saying when I was in Alaska, like for whatever reason, the moonlight was warmer up there. I mean, it wasn't
What was
much.
the temperature in Alaska?
Anyhow, I'm just telling you guys it's
No, what
something
was the
like,
temperature in Alaska? May I ask if I could ask? What's the temperature that was in Alaska at that time?
dude,
What do you think?
honestly, I don't remember. Like, I used to just make fun of flat Earth back in then. I thought I was retarded, and like I had heard like somebody say that stuff, and I was like, "Bitch, please!" And I like went outside with my thermometer, and I was like, "Oh, it's weird. It's like warmer," and I didn't really know what to think about it back then. But it was like I can't remember. It was probably -20. I don't remember.
Yeah, mine was like -5.
Hey Ron,
but
I can share yours right now. Check it out here. I'm setting it up, and then you
yeah,
can go over it.
I got
Let me
5 or
just
6
share it.
degrees.
And now I'm wondering where what temperature would be too cold. Like, he said in Alaska it was below 20 probably. What temperature would be too cold where it would not
That's what I wanted to find out. I'm like, there's no way it could be any fucking colder than this. It was fucking cold. It was December 11th, I think.
You know, I shouldn't have even mentioned it. I'm sorry. I don't mean to derail.
Well, no, I didn't think
Right.
I didn't think there would be any effect in the winter. I'm like, there's no way it could be colder in the fucking winter. There's no way. It's already too cold.
not you're
Well, that's interesting. Maybe the moonlight only goes down to like -10 or something, and the environment was cooler than what the moonlight can cool. I don't know. I'm just making
All right.
just hypothesis here.
That's why,
All right, Ron.
that was a good thing to try the difference. See how
All right, yeah, I see.
-0, -10, and -20 to see
Right.
Ron, do we need the audio on?
No, you can just read the gauge.
Okay, it's playing now. You guys should be able to see it. When did you do this one?
That was in December 11th. It was probably like 3 years ago. See, the moon was full and it was like right overhead. It was like lunar noon. So then you notice on the top of the hood, there was frost. On the side, there was no frost, and it was much colder on the top of the hood. Like, see the frost up there?
Mm-hmm.
So it's in the negative. And then on the side, it's like 6 to the positive. It varies a little bit, but...
I'll replay it.
See, it's fluctuating a little bit.
Did you have a location that you did it without frost on top?
I did it in the summertime, too. I was getting bigger. I was getting like 40-degree temperature. Something was like from the side of the car to the top. It was crazy.
Yeah, I was trying. I'm like in the winter. Next winter, try to do one without the frost. And,
Well, it got cold, and that created frost. It was colder. I didn't drive the truck all day. It was just sitting there in the driveway.
Yeah, but they're gonna say, "Well, that's good because there's frost on top."
There can't. Well, how is ice? I mean, ice has different temperatures, I guess. Then you could have colder. Like dry ice is colder. It's not natural water ice, but.
Man, I just want to say that was an amazing thing. All those people breaking out their thermometers, man. Because I've seen this like go down, like where just only one person has it, and it's like the Glober is just like, oh, I don't believe it, and that's just like I've never seen like so many people just spontaneously whip them out too. So that was really nice.
I have one too. I just didn't want to get out of bed.
Lazy.
Do it, man. Do it.
Oh, dude.
Jesse, bro, what's your explanation for the moonlight, man? Cooling stuff off. I don't have one. Do you?
Wait, was that Seafoam said that? He doesn't have an explanation?
No, that was Cyrus. It was me. I was saying I don't have an explanation for why the moonlight is cooling stuff off.
I can
I was
explain
hoping
it.
Jesse can help me out.
Oh, I just thought I heard someone else
Go
jump
for
in.
it.
Okay, maybe I just thought I heard one other person say that. But yeah, I just I don't know what happened with the mic. I thought I heard someone else say that they don't, but that was you saying that. Yeah. So, wait, you don't have an explanation for why it's doing
Like a
it, no matter what
thermodynamic.
you're.
Like it's not what we're taught. That's all I know is just like I've got no idea. Definitely cooling stuff faster than in the shade, but why?
Dude, yeah,
What-
What is being emitted from the moon?
Can I throw a couple ideas out here?
Please.
Because we'll start with it's nighttime for one, right? So because it's nighttime, it means the sun's not there. Because the sun's not there, it means everything is getting cold. It means everything above you is getting cold, very, very cold, way colder than it is on the ground, I think. And all of what that does is like those masses will be pulling up thermal from the layer beneath it if it's warmer. So like that'll just be going on until the sun comes back and it warms up everything and the cycle goes on. Does that make sense?
No.
Now let's add when we add the
Yeah,
moon into this. When we add the moon into this, we have all this light. Light has this property where it can like make these masses actually condense, and so they are actually able to absorb more heat because they're more compact. So moonlight has this way of like condensing thermal energy in a point source relationship. So that's why you can feel colder when you're on the ground if you're in direct moonlight. I mean, I've definitely felt it spontaneously and not like trying to pay attention to it. Legitimately in the winter, like it's a big difference. Basically, if it's like a super bright moon in the desert in the middle of winter, the moon actually you can almost feel like kind of burning you with some cold. But it's really just because you're in this like stream of light that is actually like electrically pulling like the caloric thermal mass of your body up to back up to equalize that energy mass. Maybe that doesn't make any sense, but maybe I can go into it a little bit more. But if anything,
like the shaded area I was in was from like a vertical object. So above my head, both like the moonlight and the moon, like the shaded area, were both open to the sky. There's nothing above my head.
I
when was
did
doing
one with
the-
my pickup truck. The bed was completely open, but one of the walls was blocking the moonlight. So the height of the pickup truck bed is maybe, I don't know, the wall on it's just over a foot, maybe 16 inches tall. So it was casting some shade, some shadow. But other than that, the entire bed of the truck is completely open to the sky. Only the part there was a little shadow area because of the wall of the pickup. And in that zone, it was warmer, just like how you displayed on the ground, just like we all did. It was the same effect. But on a full moon, you can actually see. You can see the shaded area on a full moon because it's bright. Like I went outside right now, it was too cloudy.
Right.
I couldn't get any reading. It was just cloudy, and I couldn't see the moon.
Yeah, bro, and like the fact that this is like such a easily observable phenomenon, it's like happening everywhere. Like the fact that it's not addressed is like super suspect. Like you would think this would be like, like when you're in kindergarten, your teacher would like, oh, let's go look at the moon. Like they'd have some fucking bullshit for it.
I dropped another one.
None of you are
another
scientists,
short.
and it's not being done in a controlled environment. So therefore, since you're not scientists and you are not did you read the instructions on the thermometers and what are all the inputs in the experiment? So therefore, none of this actually is taking place.
Someone mute
like, isn't that so obvious? Like, if this was you know, something like obviously if this was something that they had like a talking point about, they would be bringing it up, but apparently they don't.
Yeah, direct, measurable, right in front. Because
the
these
second
thermometers are
one.
good because the way these things work are pretty cool. How they can test, because like they're pretty accurate too. Like I mean, surprisingly so. It seems to like it's like the laser with the IR. It's like it focuses the IR and then also uses a laser. So like it's like it uses both. And I've read a little bit about how they work, and it is very interesting, like how it's able to basically fuse like laser and the IR to where like wherever it shoots the laser dot, you know, wherever your little laser pointer or the thermometer is pointing, it's like able to measure like the surface temperature. It's like it uses the IR to like project it onto like the laser part, like the actual light. Like it somehow uses the light as like a platform to then be able to measure the radiant heat from whatever the laser is actually touching. So they are surprisingly accurate, which is why they're used in like cooking and all kinds of different things.
You know what's funny? When you go through your house is all one temperature despite the material. You can go from the carpet to wood to stone, all different things. Tile, they're all the same temperature as the air. But then when you go outside in the moonlight, by the way, I dropped another one. It was from the summertime. There's another video. It's just a short vid like that. And I was getting like a 10-degree difference from the top, the hood, to the side that was opposite of the moon.
Yeah, I got
So it was in the 50. I don't know what the air temp was that night. It's pretty mild. I just kind of did it on a whim. I'm like, you know what? Let me see. I heard this is colder in the moonlight. Let me get my infrared thing, and I just I did it, and I didn't really like plan it out.
I don't know about you guys, but it just makes me want to carry one around in my pocket and like every place I travel to, like, oh, check it.
That's what I'm doing right now, man. I'm just shooting this thing everywhere. It's so consistent. I have a 2-degree difference, 1.7 to 2. Yeah. So here, I got the black body normalized now. So, I mean, I can do it one more time for Jesse. Okay. This is black body or the black lid, moonlight. Okay. Shade. Oh.
Up to
Let it
83.
normalize.
It's
Yeah,
the
it has to
materials that the moon
normalize
is
a little
made
bit.
of.
8.
The moon
This is
the moon
moonlight.
is cooling the sunlight and reflecting it.
I mean, I'm surprised we
79.
haven't heard
Back
like
into the
that.
shade.
I'm surprised we haven't heard that like photons give off cold light or coldness or something. Something.
The moon's
Some,
rock
some
is
frigid,
reflecting photons.
some frigid ice that blasts along with the photons.
I was waiting for a well, actually, as an omnivore
It's the
thing.
sister photon. What's the sister photon that's coupled?
The reflector that the Apollo mission left switches the photons into.
Oh yeah, that's it. It has to be the reflector. What else could it be? That's right.
The golf clubs that they left up there, reflecting the light and cooling it.
They left them on the dark side of the moon, right? That's why no amateur, astronomer can see them, right?
They actually could. They drove the golf balls like way farther because of the gravity on them. So much less.
You can't see them from Earth because they're too small.
So, Seafoam, what is your explanation as to how this is functioning? How this moonlight is colder?
I really don't know, actually.
It's pretty simple. The moon and the sun are the same size. They're opposite charge. There you go.
Well, do you think it falsifies the heliocentric interpretation of the world, of the Earth and the sky?
I mean, I think there's probably something else going on. I don't think the light itself is cooling things down. It might be something else. I just don't know what it is.
I mean, what is it? It's the same wind that's flowing across, like, for me here. So the same convection cooling, the same radiative cooling, the same conduction to the, 2x4s. There's one on the right, one on the left. So you can X all those out. So what can it be? Because we have 3 modes of heat transfer: conduction, convection, and radiation. So what's going on here?
I mean, I don't know what's going on. I just don't think it's the moonlight.
Well, it is though. I could show
Why
you
is it
again.
directly
You
correlated?
don't
Yeah, why
believe
is
it.
it directly correlated with moonlight versus moon shade? Wouldn't that isolate that it is the moonlight is the different thing in that equation? Either moonlight or no moonlight?
Yeah.
What
I mean,
else changes when you
Yeah, it's not
switch
like
from
thing I would like
moonlight
to
to
see
non-moonlight?
if you redid this experiment in the exact same location, but without the moon, right? Would it then be completely consistent throughout?
Yes.
Yeah, like the effect's
I
only
mean,
there when the moon's there, right?
that's what I would like to see before I jump to any conclusions.
What about during a new moon, Napalm?
Well, I think you should, if somebody wants to try this, right, try it under a full moon, so you obviously get the most effect that you're going to have. And then it would be interesting if you had something that, like a 2x4 that was suspended above the ground that would cast a shadow, and that shadow would move throughout the night in the same way that a shadow would move with the sun during the day. And you come out and test at different points, and you have the same medium below it. So the shadow is going to be cast across the same medium. You're going to have the same conditions. You're going to have the same surface. So you're going to have the same elevation, all that stuff. You're just going to get a varying shadow as it goes throughout the night, and testing to see if it still is a correlative relationship between the shadow and the moonlight. So you have a
I
progression.
did that last night, and it was the same, man. As the
Same
shade
result.
moved, it's the minute I crossed that line, boom, the temperature immediately drops.
So then what else could it be,
Which is
right?
like, all
That's
right.
basically eliminating well, it's got to be something else going on because I don't have an explanation. Like, I get it, but we can do the same thing with sunlight to show that, okay, if I'm in the shade, it's going to be cooler than in the sunlight, and I can follow that shadow and show the same effect, but we get the opposite effect with the moon. Like, it seems as though that's the results that we're getting. Now we need to figure out an explanation for it. To me, it's pretty
Now I need to
definitive.
point my spectrometer at the moon. Yeah, so it's not the conduction, it's not convection. So it has to be
Right.
the radiation coming in from the moon. But it's like anti-radiation.
Yeah,
It's like
anti-radiation.
radiation
Correct.
inverse.
Yep.
Yeah,
It's basically
all
like
right.
it's sucking
Going out
up
here.
the thermal mass of everything with light, because it's restoring it back up to the other places where it is even colder in the higher atmosphere. Like that light is a continuous like circuit, sort of moving through the higher atmosphere. That's why I think it's like cooling, but it also seems to like be around weather patterns, like condensing the atmosphere, bringing it together, causing like storm activity and that kind of percolation.
Well,
Could also be, instead of like sucking up the heat, maybe it's radiating cool waves, whatever those are. I've got no idea.
It would
Right?
be like noise
Could be the
canceling,
emission.
right? Noise canceling headphones. You get a noise canceling light, like a heat canceling light, a cold light and a hot light.
Can I remind everybody that the AC current that Tesla invented is based on the moon and the sun charging and discharging the Earth. So it's right there for us.
Now that you bring that up,
sorry, so are you familiar with like a Joule thief circuit?
Yeah,
something like that. But using
could be
that
man.
light as a wire, sort of, because like the air is itself a conductor.
Okay.
And the air is itself diamagnetic. Go ahead.
Well, have you seen
I like
this?
that theory. I like that. I like keep going with it. I'm sorry. Go ahead.
Oh, go ahead. No, but have you guys seen this? This is just going right along with what you're saying, I think. But I shared it on it should still be the screen share. It's called the sacrificial anode. And basically, like, one of them like deteriorates because of the action of the other in like the cathode anode relationship, and it can cause like pitting. So like perhaps could that even be what the moon craters are? Is actually this like electrical exchange process
that actually happens in your car battery. That's why the lead plates deteriorate between the positive and the negative, and that's why your battery just wears out.
Happens on boats too. That's why they put sacrificial anodes on there.
Yeah, they put like a zinc pad so that the hull doesn't deteriorate.
From electrolysis, yeah.
What I saw.
Man, this is so cool.
I don't know that we really need to call it reverse radiation either. We've all been told that there's no true such thing as cold. There's only heat and lack thereof. But we don't really have any evidence to that. No one's ever found absolute zero. So, I mean, for all intents and purposes, like this is just cold radiation.
Right.
Yeah.
Right.
Everything
Yeah.
has an opposite. You have an explosion and an implosion. There's like everything has a yin and yang.
Exactly.
But she's right about that. There's no such thing as like heat just flows from hot to cold, and there's just heat. So, like it goes down the gradient, right? So if you have an area, if you have an object that's whatever 80 degrees, the other one is 70, that the heat is going from the 80-degree object to the 70-degree object. And if it's close enough, it can radiate it off and all that shit. If it's touching it, then it's by conduction. The wind and the object, that'll be convection. And radiation would be in the infrared scale, the infrared electromagnetic waves, right?
Yeah, most of the
Yeah,
time
but
at
the
the boundary
wind,
layer is when you're going to see condensation, right? That's why we see rain in between the cold front and the heat, right? When the cold front comes up against the heat, that's when you have the that's when you have condensation occur as well. So this happens
well,
on
the
your
cold front
window.
is a low pressure system. You have a low pressure and a high pressure system. And then the
Correct.
pressure, as you get lower, like when you go in the upper atmosphere, the temperature gets really cold. So there is a correlation between air pressure and temperature. And the same thing, pressure voltage is pressure, right? Like electrical current is referred to as pressure, the pressure on the electricity.
Yep.
Is the analogy. But it's an inverse. It's an inverse. The lower the air pressure, the colder the temp. And the higher the electrical charge, because the higher you get from the earth, you keep gaining 100 volts every 3 feet.
See, I was kind of like Omni when I first saw this stuff, like on YouTube and all that. But when you do it yourself, it's something else, man. You're like, oh man, this is legit.
That's what I told the doubters. I'm like, go spend $20. Don't believe me. Do it yourself.